Okay, I think we made it up to section 28 now. Let me just go to the index, and this is something you can do too. And if you want to get to section 28, just touch the red thing, it'll bring you right there. All right? So again, let me just remind you a few different things. One thing I want to remind you of is that that we are in exercise 28 now. The materials are exercise 28. And by that I mean, there's going to be contents that you should read through, examples that you should think about, and then see if you understand the material, all right? My name is Ron Bannon. This is a draft version of Webster Wells Advanced Algebra course. This material is being prepared for the prison mathematics project participants only. This will be published at a future date. My name is Bannon. My email address is Bannon, B, the @ symbol, NNON.US. All right, so if you need to reach out to me, please do. All right, what's expected from you? What's expected is you study the material that Wells presents to you. So the material here is going to be, there's going to be equations, and certainly, I got to be honest with you, I think nowadays if I gave these equations to students in algebra, even if it's at what I call a good school with good students that are prepared, what's going to happen is they're going to bog down and possibly do these the wrong way. So you might say, oh, Wells is being tricky. Not really. He's seeing if you understand the prior patterns, and I really mean that. Do you understand the prior material? Okay, let me go through this. As I go through it, someone can say, oh, it's in the blue area. Why don't you just look at that? Yeah, you could. There's no need to watch these videos. All right, but if I were doing this problem over here, I'm going to say this is a standard question that could be asked of any student in math, in a math course that's involved in beginning algebra. So the first thing to do is LCD. By inspection, I notice the LCD is x plus 1, x minus 1, and that if you multiply that would be x squared minus 1. It's different per square. What do you expect to do? Multiply both sides by the LCD. All right, again, a little better at this. So, the LCD times the first term. What would that give me? That would give me 1 times x minus 1 minus, oh, you know what I noticed? I got it wrong. I copied wrong. So I said that's the LCD. And not that it's that big of an error, but let me go over that again. I apologize for that. I wrote the wrong thing down. I'm daydreaming. So it's really 1 plus x, 1 minus x. All right? Let me go multiply both sides by that again. What do you get? You get 1 times, 1 plus x would cancel. You get 1 minus x minus x. All right? Let me repeat this. This over here, if you multiply out, would be 1 minus x squared. Difference of perfect squares. What do you get on the right side? Well, you get 1 minus x squared. All right, what do you get on the left side now? Simplify it. You get 1 minus x equals 1 minus x squared. You get 1 minus 2x, 1 minus x squared. I'm going to be using the zero product rule to solve this. The way I would do that is I'd probably subtract 1 from both sides and add 2x to both sides. You get 0, 2x minus x squared. I would factor out an x, and you've left off with 2 minus x. The zero product rule, look for when the factors equal 0. Well, x equals 0 when x is 0, and the factor 2 minus x is equal to 0 when x is equal to 2. I seriously would check that, but the bottom line of what I'm pointing out, I want to make sure I got the right answers looking at the key. You might say, oh, your work looks different. Yeah, this is me neating it up with typing it, and you should learn that, all right? So, this would be what I would do on paper, which is rarely looked at anymore. And what I mean by that, people really don't, prepare things on paper too much anymore. What they do is they type it up. And that's an important skill set to acquire, being able to typeset mathematics. All right? More on that later. Right now, I wouldn't worry so much about that. The other thing is I check it. And someone says, why do you check it? Well, I want to see if it's right. So to check x equals 0, I can't say this enough times. You only check it here. And what would you get? You would get 1 minus 0 equals 1. That checks out beautifully. Now, 2 is also easy to check. I'll write that down for you. I'll see if it works. What do you get? 1/3 minus 2. And what do you get on bottom? 1 minus 4, which is minus 3. And they said it's equal to 1. Well, that doesn't look too bad. That's 1/3. Let's see. You would get minus a minus 2/3, which is plus 2/3. And certainly 1 plus 1/3 plus 2/3 is 1. So this also checks. So I'm convinced that what I've done is correct. All right? And certainly the key is matching it. All right, let's go to the next one. Very similar. LCD, pretty similar. I mean, these could be done at most schools that teach algebra. The LCD is x minus 2, x plus 2. And what is that going to give you? X squared minus 4. All right? And we spent considerable time in the past doing LCDs. Multiply both sides by the LCD. What do you get? 2, x plus 2, minus 5, x minus 2. And on the right side, you just get 2. Let's go through it. You get 2x plus 4 minus 5x plus 10 equals 2. And what do you get there? Minus 3x plus 14 equals 2. Minus 3x. I'll subtract 14 from both sides. That's minus 12. And x turns out to be 4. All right, I'm not going to box it yet. What am I going to do? I'm going to check it. All right, I'll look at the answer key later. What would you get? I'm checking. There's only one solution. I believe there's only one solution. So 2. 4 minus 2 is 2 minus 5. Well, 4 plus 2 is 6, right? 2. You would get 16 because 4 squared is 16. 16 minus 4 is 12. All right, so I'm going to say the common denominator would be a 6. The right side is 1/6. And let's put this down. What do you get? Let's see. 3 times 2 is 6. So what do you get? 6 minus 5. Well, 6 minus 5 is 1/6. It checks beautifully. That's my answer. Again, what's my recommendation? Check it. You see it right over here. All right? By the way, I also did this over here. Again, I want to point out there's a difference between my scratchy work, using a piece of paper and pencil, and my typeset work. You really do need to start preparing work so other people read it, and that is typing it up. This stuff is being typed up using LaTeX, by the way. And, maybe later I'll introduce that to you. Right now, and not worry about that. You're learning algebra. That's what you're learning. All right? Let's go to the next one. And again, I'm looking at the next one. Again, it really is a very standard algebra question. And the LCD, I'll write it down for you. Maybe more work, by the way. But 15 and 5, the least common multiple of that would be 15. Then I see a factor of 7x minus 16. So far, the first 3 problems, fairly straightforward. What do? Multiply both sides by the LCD. That's multiplying every term. I would get 6x plus 1. The 15 cancels, and I get 7x minus 16 minus, what would you get there? You would get 2x minus 4. That's the top. 7x minus 16 would cancel, and left off at 15 equals, well, what would I get there? Let's see, 5 goes into 15 3 times. I would get 7x minus 16, and I'd get 2x minus 1. Looks like it might be some work, right? Let's go through it. And certainly, when I say go through it, I mean really go through it. So what do you get over here? Let's see, 6x times 7x is 42x squared. And then you get minus, let's see, 6 times 16, that's 60 and 36, so 96x. And then what do you get? You get 7x minus 16. Let's do the next one. What do you get? Minus, that's 15 times 2x minus 30x. And let's see, what would you get? You'd get 4 times 15, 40, and 20. That's 60, right? So plus 60. All right, I want to continue simplifying that side. And so I'm going to combine all those things together. 42x squared. All right, see, that's a lot of work, isn't it? So minus 96 plus 7. That's minus 89. And that's going to be what? Minus 119 then, right? And then you're going to get plus 44. Minus 16 plus 60 is 44. Let me go this side, a little more challenging for me, but I'll do it in stages. 3, 14x squared. I think I can handle that. So minus 7x minus 32x is minus 39x. Let me double check that. Let's see, minus 7 minus 32 minus 39. Then get plus 16. Let's keep moving. 3 times 14x squared, that's going to be 30 and 12, which is 42. X squared. And let's see, 3 times 39, that's going to be, well, 3 times 30 is 90. And 3 times 9 is 27. That's going to be minus 117. And then you're going to get plus 48. I'm going to look at this, and what I notice immediately, that 42x squared, if I subtract from both sides, disappears. And now I'm going to add 119x to both sides, and you would get 2x. And then I would subtract 48 from both sides, I get minus 4. What's x? X would be minus 2. Oops, I'm not going to box that. So, someone said, what are you going to do now? I'm going to check it, right? Now, someone's going to say, I'm exhausted, I don't want to check it. You can look at the answer. I'm not saying otherwise, but I do want to check it. So let me take this over here, and I'll plug in minus 2, see if it's right. So minus 2, what would you get? 6 times minus 2 is minus 12. Minus 12 plus 1, I'm doing the first term, is minus 11. What do you get for the next guy? It's going to be a little more difficult. Let's take a look. You get minus 4, minus 4 is minus 8. Right, again, think x is minus 2. What do you get on the bottom? Minus 14, minus 16, that's minus 30. Let's do the right side. What do you get? Let's see, minus 2 minus 1 is minus 5. You get 5 in the bottom. This is minus 1. All right, let's go for this. What do you get? Minus 11 fifteenths, and this is going to be minus 8 thirtieths, which is going to be minus 4 fifteenths. Well, that looks reasonable to me because minus 11 minus 4 is minus 15, and minus 15 fifteenths is minus 1. So this checks out beautifully. All right, so I'm going to say this over here. Now, again, they're giving a warning over here, and I'm going to read that warning to you. It says over here, I did the check. It says, at the very least, you should check that the solution x equals minus 2 does not produce a 0 as a divisor of the original equation. And you should notice that in the original equation, if you plugged in minus 2, you would not get 0 as a divisor. Now, someone says, why do you need to do that? Sometimes by multiplying both sides by the LCD, you introduce an extraneous solution that would be incorrect when plugged in. And you don't know that until you plug it in. Now, Wells is big on talking about that, but in a different way, not by checking it, but by observing it before you proceed forward. I also do the check over there. All right, let's do the next one. And certainly when I'm doing this over here, I'm kind of looking at it, and I'll be honest with what I notice immediately, that I'm not going to say you can't multiply both sides by the LCD, but what I notice immediately is maybe I could rearrange this problem to make it a little bit simpler. And certainly someone says, why would you do that? I'll do it both ways for you. But I'm gonna rewrite this as x squared minus 1 minus 1 over x squared minus 1 equals 1. I'm going to combine those two terms together on the left side. And what do you get? X minus 1 equals 1. I'm now going to factor both top and the bottom, and I get a nice reduction out of it. So let me put that down for you. X minus 1, x plus 1, x minus 1 equals 1. Now, immediately what I know is I know that the factor x minus 1 cancels out provided x is not equal to 1. All right, now I'm gonna do that, and then I'm looking at this and I'm wondering, could I figure out the solution to that problem? Well, just to remind you what that problem looks like, it looks like this over here. And I'm going to say that's fairly easy to do. What do I know about that? X equals 0. That certainly can be checked in the original problem, by the way. All right, so I'm going to say over here, that's the way they did it. They did that and they checked it. All right, they checked it. I'm going to do it another way, though. And the other way I'm going to do it is the way that most algebra students would do it nowadays. They would write the LCD down, which is x squared minus 1. They would multiply both sides by x squared minus 1. And what would they get? They would get x minus x squared minus 1. It's actually 1 times that, equals 1. Then what do they get? They get x minus x squared plus 1 equals 1. There's a point to this. I would subtract 1 from both sides. I would get x minus x squared equals 0. I would factor, and what do you get? X minus, I'm sorry, I made a mistake there. You get 1 minus x equals 0. Well, if you weren't thinking, what would you say? Oh, x equals 0 or x equals 1. But if you check the 1, you realize it doesn't work. And why is that? A division by 0. It's an extraneous solution. It gets crossed off, but x equals 0 does work, and this should be boxed. We've already checked that. All right? Let's do the next one. And certainly when I'm doing these things over here, someone says, well, how would a student in most algebra classes nowadays do this? They'd get the LCD. I kind of want to warn you against that. I'll tell you why. The LCD is really crazy. I will write it down for you. And by the way, I'm not saying it would be wrong to take that approach. I'm just thinking maybe there might be simpler to do. Something simpler to do. I'm going to erase that. Again, I'm not saying don't do it. I'm just saying I don't want to do it. It just seems like too much work to me. So I'm going to erase that, and I'll go through what I would do. All right? Now, certainly what I do may be different from what you do. But here's the deal. We can't disagree upon the truth. There's a truth to this problem. I'm going to actually take each side separately and add them together. I'm going to do that one step at a time. Let me put the bar down. You would get x plus 8. I'm adding these two rational expressions together. X plus 9. Again, we're hoping you're getting a little bit faster at this. This will be x plus 10. And this will be x plus 6. Now, what do I get over here? I would get 2 times x plus 9, which is 2x plus 18 plus 5x plus 40. We'll simplify that later. What do you get on the other side? Well, you get 3x plus 18 plus 4x plus 40. Let me keep doing that, writing it down over again and again for you. What do you get? X plus 8, x plus 9 equals x plus 10, x plus 6. What goes in the numerator? Looks like 7x plus 58. 7x plus 58. Now, I hope you realize that you're looking at something that's remarkable. All right, now what I mean by that, these two fractions, for them to be equal, one of the possibilities is that both tops produce a 0. Let me write that down for you. So 7x plus 58 equals 0. 7x equals minus 58. Oh, I'm sorry, I went way too quick there. I have to erase that. And then divide both sides by 7. What do you get? X equals minus 58 sevenths. All right, so right now I say that would produce a solution to the problem, and the reason that both fractions would be equal to 0. And by the way, the trouble numbers are minus 8, minus 9, minus 10, and minus 6. They're trouble numbers. All right, my next thing is going to be, since I'm going to look at this, I'm going to say the other case, I would, divide both sides by this, 7x plus 58, with the understanding that, there could be trouble if it's 0, but I'm just going to get rid of it and see what happens. And what would you get? You'd get 1. And by the way, what I'm saying over here is this is provided x is not minus 58 sevenths, because if it was, I couldn't have done that. So I'm just going to say the only solution I could get from this problem is if x is not minus 58 over 7. And again, this is not something you'd expect a modern algebra student to do. And looking at this, I'm going to say, this looks pretty simple to me. What am I going to say? For those fractions to be equal, their denominators need to be the same. I'll write it down, and we'll solve it. What do you get over here? X squared. And let's see, 9 and 8 is 17, right? Plus 72. This gives me x squared plus 16x plus 60. I'm going to subtract x squared from both sides. That's fairly simple. And I'm going to subtract 16x from both sides. That would give me x. I'm going to subtract 72 from both sides. and that would give me minus 12. All right? So I'm going to claim that these two guys are my answer. Now, I realize for a lot of students, you're looking at that saying, you know, maybe I should check that. But I want to point out, the only really troublesome numbers now are minus 8, that would make this 0, minus 9, that would make that 0, minus 10 would make that 0, and minus 6 would make that 0. So I'm going to say it's not bad. Here's the deal, though. I really should check both of those answers, all right? Now, before I do it, I want to tell you this over here. That solution is given to me, right there. And let's see if they got the minus 12. They have that right here. So I have this. And I want to point out, I go through checking both of those for you. I don't want to bore you with the detail. However, I don't mind boring you with the detail. I don't mind going through the work. But the point is we want you to go through work. What do? I check. Minus 12, they say it's fairly easy to check. And they also go say, although the other one's a little bit more difficult, I'm going to say a tad bit more difficult, it's also verifiable. Now, what do I mean by that? Checking this one over here is verifiable, and you get something pretty simple. All right? Now, I'm going to look at number 6, and I'm not claiming that what I'm doing is what you would be doing. And here's the deal. You do it the way you like to do it. All right? Now, I'm looking at this thing over here, and I'm thinking the LCD is going to be too much work for me. All right? So someone says, why is it too much work? I just think it's too much work. So what I want to do is I want to go through some simple things that might help me. All right? They may not, though. I'm going to do divisions first, and I'll write this down for you. So I'm going to take the 2x minus 3, and I'm going to divide it. Now, let me repeat this. A modern-day algebra student would not do this because they would think, it's too many steps to take. All right? This goes in one time, and I'll write this down for you, and that's 2x minus 3. And if you subtract that, you'd get 2. So the first term here would turn out to be, well, I got a 1 plus 2. That's unfinished business divided by 2x minus 3. Let me keep going. I'm going to do the next guy. All right? Now, someone's going to say, why would you do the next guy? I have to. If I did that division, I got to do the other one. Let me write it down for you. And I'm saying x squared plus 4. I'm dividing that into x squared minus x. I'm going to say one time. What do you get? X squared plus 4. And what do you get there? You would get minus x minus 4. Well, I'm going to write that down for you now. What do I get? I get 1 plus unfinished business. Well, I didn't divide minus x minus 4 by x squared plus 4. And what's that equal? It equals 2. Now, immediately someone says, that's an awful lot of work, and I don't think it helped me at all. I still have the same denominators. And I agree, you have the same denominators. But I have an advantage now, and I'll tell you what that advantage is going to be. I'm looking at it, and immediately what I notice is 1 plus 1 is 2. So what I'm going to do is subtract 2 from both sides. And I actually get a simpler equation. All right, let me write that down for you. So I'm going to write a simpler equation down now. All right, it's equivalent. I have no trouble so far. So I get 2 over 2x minus 3. Now, I'm looking at this, that term that says plus minus x minus 4. I'm going to write it a little bit differently. I'm going to write it this way over here. Minus x plus 4 over x squared plus 4 equals 0. All right? So again, what I do, I subtracted 2 from both sides, and I simplified this fraction over here. Now, someone can say, are you going to multiply both sides by the LCD? No. I'm going to do something a lot of modern algebra teachers say you shouldn't do. I'm going to do this. I'm going to put this down. Again, your approach might look different, but the truth in the end can't be different. All right? Now, a modern-day algebra teacher has been warned repeatedly never to say cross-multiply. All right? It confuses people. That's why they shouldn't say it. But I don't see it being bad. It's really the same thing as multiplying both sides by the LCD. And what's the LCD? Well, it's pretty simple. It's 2x minus 3 times x squared plus 4. And if you multiply both sides by the LCD, you'd end up with this equation here. 2x squared plus 4 equals 2x minus 3 times x plus 4. Now, the students that are familiar with cross multiplication, it looks like cross multiplication to them. I'm not saying it doesn't, but we multiplied both sides by the LCD. What do you get? 2x squared plus 8. And what do you get on the right side? Well, let's take a look at it. You get 2x squared. You get 8x minus 3x, which is 5x. And minus 3 times 4 is minus 12. Subtract 2x squared from both sides. That was pretty simple. They just disappear. And add 12 to both sides. You would get 20 equals 5x. Divide both sides by 5, and you would get x equals 4. What do we recommend? Go back to the original equation, plug in the 4 to make sure it makes sense. Of course, I'm not going to bore you with that detail, but it's over here. I actually did it and put it down for you. All right? So that's like 6 problems. I know it's tough. There's no doubt about it. So what I want to come over here is, what happens next? Like it always does, exercises. So someone's going to say, I think I understand that there's no real reason to practice. There's even more reason to practice in case you really want to get over that thinking you don't need to practice. You need to practice, and you need to practice the rest of your life. It's that simple. And I mean that with any subject area, including reading. Reading is something, you might say, I know how to read, I'm not going to read anymore. That skill set disappears. It really does. You need to read, you need to write, you need to do arithmetic, and if you're thinking about algebra, you need to do algebra. All right? But I'm saying over here, you're going to need to practice these problems over here. Do they start simple? Yeah. Do they get more complicated? Yeah. Here's the deal, though. I put enough work down for students to look at if they need the support. But the bottom line, every question has an answer. However, could I have made a mistake? Absolutely. If you think I made a mistake, bring it to my attention. All right? I'm the only one who's prepared this material. All right? I'm the only one who did that. All right? My goal here is to make this thing, I can't say perfect, but better. How do you make documents better? People give you feedback. They tell you something. They tell you something's wrong. They tell you what's wrong, and then I look at it and I correct it. And I'll give you credit. I'll give you credit. Now, someone said a lot of problems, and they really do get bad. All right? We're hoping that we gave you enough information, during the examples, and hopefully by reading the section too, that you can do those problems on your own, once you study it though, all right? Then you get to this stuff about SAGE, all right? So what's SAGE? SAGE is a computer algebra system. Yes, we've mentioned this many times. It's free. What do you mean by that? You can download it. You go to this website over here. You can download it, or you can use the interactive web-based application. What's our recommendation? You type stuff in. That's our recommendation. You type all this stuff in and see what it gives you back. All right? I realize still students may be concerned about something in the notes. You can reach out to me by email. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. Again, if you have a concern, please reach out to me. All right? Again, my name is Ron Bannon, and we're just going through the document one section at a time. Of course, the next one would be 29 and then 30 until we get to section 139. There's a lot of material. And certainly, I hope you realize a lot of this stuff, very familiar to algebra students, but Wells does twist the problems. All right? He twists them so that I think a modern-day algebra teacher would actually have trouble with Wells's unless they read the material. All right? Now, again, I think if you like playing around algebra, it's not bad, though. All right? Thank you for your attention. I really appreciate it. Bye-bye.